What's up guys, back with another video. This is part 2 of Kirchhoff's law, KVL, Kirchhoff's voltage law. So we'll shortly discuss. So let's get the principal idea first. If you watched my first video on Kirchhoff's law, KCL, I don't have this part for KVL yet on Master Guide. So let's get the principal idea. So basically, the voltage across the whole circuit is equal to 0. So remember in circuits, like a series circuit, you add the voltages, the summation of the voltages will be equal to the voltage total. So it looks like this, right? So basically, yeah, wait, why did I erase that? This whole thing minus our voltage total is equal to 0 because they're equal. You know, it's like KCL but with voltages now. You get what I mean? Since they're equal, if you get their difference, you don't have a difference. They're equal to 0. So, yeah, so it says here as well, later we can use Cramer's rule for a 2x2 matrix, or just a simple system of equations. This is absolutely the fastest way. Like, this, no need. I'll show you that shortcut, system of equations. Okay, let's visualize that, shall we? So, just like KCL, we have to assume current directions. Can be in any way. I'll show you right here. So, let's say here we have a clockwise rotation. Basically, we move clockwise. You have to take note of these right here. As you can see beside the resistor, these signs. We have here positive, negative, positive, negative, positive, negative. Yeah, we have here on our voltage as well, our battery. So we move. So, okay, plus. So plus V1. Next. Oh, okay. Wait. And now next it meets plus V2. Okay, next it meets plus V3. And then we move here. Oh, wait, it's negative. We meet at a negative. So minus VT. You get what I'm trying to say? And if you look at that, it's now, if you rearrange the equation, you get this, right? So the voltages are equal to your voltage total. Simple circuit concepts. Now, what if we assume the opposite direction? We assume a counterclockwise rotation. So we start from here. So we meet a negative, minus V3. We meet a negative, minus V2. We meet another negative, minus V1. Then we come here, it's positive, plus VT. Again, if you arrange the equation, you get this. This is the same as the equation above, over here. So V1 plus V2 plus V3. Basically, the voltages equate to your voltage total. And, you know, these will, if you arrange, you know, the difference is equal to 0. So, let's solve, shall we? Okay. Let's assume directions. I want this to be clockwise. That is ugly. I want this to be clockwise. I want this to be counterclockwise. Let's do it. So, we move here. Alright, so that's our V1. Plus V1. So V1 plus move. And plus our V3. And then we move again, minus our VA. but let's just say we have a value for that, so let's just do minus 10 equals to 0. Other side, but this one's counterclockwise. So move v2. Oh wait, I want that to be right. So v2, so plus v2. We move plus v3, and then we move, I guess, negative. So minus 20 equals 0. Simple as that, right? Then let's actually transpose our VTs. Let's put in standard form. So equals 10 v2 plus v3 equals 20. So what do we do from here? Just like in KCL, you're just gonna be substituting values. So yeah, I mean, what else can you do from here, right? Let's substitute. So I wrote it down over here. Remember our formula for voltage is voltage equals current times resistance. Okay, let's substitute. So V1 is I1 times R1 plus I3 times R3 is equal to 10. Other equation. I2 R2 plus I3 R3 is equal to 20. Next, we wanna isolate. We wanna eliminate variables as much as we can. We wanna deduce, right? How can we do that? We look at IG. We're gonna use some concepts here. So we know that this is in conjunction with KCL, because we're gonna look at the currents, right? We know that I1 plus I2 is equal to I3. So yeah, if you notice, I'm actually using the same circuit as we used in the KCL video. So these currents, they make up this current. You feel me? Like, I mean, look as well as recalling your knowledge on circuits. Current and parallel are added, right? If you think about it here, how the current moves and such, they combine towards this current from here, or you can assume the direction, right? This current will split into these two directions. Well, yeah, you can watch my KCL video. You know that I1 plus I2 is equal to I3, and so we substitute again. We are simplifying the equation. I1 R1 plus I3 is I1 plus I2 R3 is equal to 10. Yeah, and then other side, I2 R2 plus I1 plus I2 and R3 is equal to 20. Then from here, we're gonna substitute, we're gonna distribute R3. I1, distribute. So it's gonna look like I1 R3 plus I2 R3 is equal to 10. Next, other equation, I2 R2 plus distribute I1 R3 plus I2 R3 is equal to 20. Alright, what next? Next, we're gonna combine like terms. But wait, how can we combine like terms? You know, this is not 1-to-1 to this, right? I1R1 isn't 1-to-1 to I1R3. But remember a concept. So this here, this is one sector. This is one sector. They're called closed loops. So if you think about it like that, you can add the resistors. R1 plus R3, right? R1 plus R3 is 50 ohms. So yeah, I mean, if you look here, second equation, if you go look at you got two I2s. You can combine I2R2 and I2R3, because you can also combine the resistors. Here, R2 over here can combine with R3. Just try to think about this separately. Yeah, if that makes sense. So, you combined it. I1 R13. Right. Yeah. Plus I2 R3. Alright. Is equal to 10. And then next we combine I2s. I2R, so I2 R23 plus I1 R3 is equal to 20. Alright, so this is where we come in with the system of equations. The Kramer's 2x2 matrix, I'll do that later. I just wanna, to people who just wanna study the day before the exam, I'll show you the shortcut. I'll do some simple system of equations. These are taught during entrance exams. So when we use these, when we're looking for two variables, right? In algebra, in the standard is that you're just looking for one variable, right? But here we're looking for two variables. We're looking for I1 and I2. That's why we got rid of I3, so that we can limit the variables that we need. So we're looking for, let me just write this, I1 and I2. Okay, I'll teach system of equations real quick, the simple one. I have here, did I not write it down? Okay, wait, this is where the video cuts. Actually, wait, no, I'll just trim it. Example, x plus y, wait, no, 2x plus y equals to 19, x plus y is equal to 13, and then it is 10x plus y. Okay, so here we have an example here. We have here three equations. We got 2x plus y is equal to 19. We got x plus y is equal to 13. And we need to look for 10x plus y. So over here, 10x plus y, you already assume that you got both variables. How do we get x and y from these two equations, these two linear equations? Well, all you need to do is subtract this equation. Get the difference of this equation and this equation. What do you mean? Just 2x plus y minus x plus y equals 13. So 2x minus x, 2x minus x is equal to x. Y minus y is 0. And then 19 minus 13 is equal to 6. So what is the idea here? The idea here is that you want to cancel out a variable. You want to cancel out a variable. As you can see here, we canceled out y. We cancel out y. Yeah. I mean, it's basically as simple as that. And since we have x equals 6, we can just plug that in. We can plug that into either equations. Let's do to 13. So x plus y is equal to 13. Knowing that x equals 6, we have 6 plus y is equal to 13. Transpose 6 to the other side. We have y is equal to 13 minus 6 is 7. So we have 6 and 7. Okay, anyway, 10x plus y. That's what we're looking for. Then, so substitute our values. So 10 times 6 plus 7, that is, whoa, 6, 7? So anyway, yeah, that's system of equations. You just want to cancel out the variable. You cancel out a variable by, you have equation, okay, let me just, equation 1 minus equation 2. And then you get one of the variables. And then you substitute. So I hope that was simple. Okay, let's do system of equations here. Given two linear equations, let's do it. So let's write it down like this. Actually, wait, let's substitute in our values first. I1 and R113. R113 is 10 plus 40. You look here. So that's 50 ohms. Plus I2, we're looking for I2, remember. And then our R3 value is 40, yeah. Is equal to 10. Next equation. We got I2. What is R23? So remember, this plus this. So 60. And I1 R3. R3 is 40. It's equal to 20. So yeah, okay. Let's put down our equations here. What I'd like to do is I like to the equation on top to be subtracted. I like to use the whatever it equates to. Like you see here, 20. 20 is bigger than 10. I just like to use that on top, the bigger number on top, so you won't get confused as well. We copy this equation, but let's structure it in a way where it follows the first equation. So the term with I2 goes first. Yeah, that's the word I was looking for. 240 plus I1, what is this? 50 equals 10. Then remember what I taught you. But wait, we can't really subtract a value here, right? like at first glance you can't, but you need to, okay, how do you subtract a variable here? You can't see it, right? Because 60 minus 40 is 20. 40 minus 50 is negative 10. You don't see it yet. So what you want to do is that you want to manipulate the equations a bit so that you can eliminate one of the variables. How do we do this? I'll show you. The idea is that you want okay, let's choose this pair. You want I2 and this I2 to be equal to each other. You want this term to be equal with this term. We have 60, we have 40. 60 and 40. The lowest common multiple is 240. 60 needs to be multiplied by 4. 40 needs to be multiplied by 6. You see where I'm leading with this? So now we have 240 and 240. Of course, if you subtract, 0. So knowing this information, what you do is, multiply this whole equation by 4 and this by 4. And then this whole equation by 6 and this, and the other, of course, whatever you do on one side, you do on the other side. Multiply the whole equation. So, yeah, it's as simple as that. Okay, let's do it, shall we? So, we distribute. 4 times 60 is I to 240 plus 40 times 4 is 160 is equal to 4 times 20 is 80. And then here we have 6 times I240, well, basically 6 times 40 is 240, as we said. 6 times 50, so it is 300. Is equal to 4 times 20 is 80, 6 times 10 is 60. So 60. Then we do our subtraction here. I keep using this color. Let me use blue. So blue. Let's subtract. So these, they cancel out. So now we have this. 160 minus 300. That is I1 negative 140. And 80 minus 60, so 20. Divide both sides by negative 140. Divide both sides by negative 140. You get I1 is equal to negative 1 over 7. What is that? That is, okay, is equal to negative 0.14. Negative 0.14 amperes. So yeah, we have here our I1. Then, remember what I said? We just substitute it back. Remember when I told you? Then after you get the first variable, you go substitute it back into an equation to get the second variable. Let's choose. Let's do I1. This is, the first equation. I'm sorry, it's 1:30 a.m. So, okay. Wait, what? Okay, let me just expand it. I1 is negative 0.14 times 50 plus I2 40 equals 10. So this whole thing goes to the other side, you transpose it. This divide. So I2 is equal to 10 minus negative 0.14 times 50 over 40. Alright, let's do that on our calculator. 10 minus negative 0.14 times 50 over 40. This will give you I2 is equal to 0.425a. And then if you want to get I3, you just add them, remember? I1 plus I2, so I got to I3. Let's write it down over here. I1 plus I2 is equal to I3. Where I1 is negative 0.14 plus 0.425. This will give you 0.14. Our I3 is 0.285 amperes. Then we can get our voltages. So we need V1 equals to I1 R1, V2 is equal to I2 R2, V3 equal to I3 R3. Then, yeah, we just substitute in our values. So V1 is equal to negative 0.14 times our R1 is 10. Our V2 is equal to what's our I2? 0.425. And then what is our resistors? 20. And our V3 is equal to 0.285 times 40. And yeah, so you can do that by yourself. But yeah, thank you for listening. And if you, yeah, you get your voltage. Okay, thank you for listening.